All right, well, thank you everyone for joining us today. It's such a pleasure to be here. As many of you know, I'm Christine Stewart, and I have the great pleasure of serving as Devrina's major professor. For some of you that new this year, I've been on sabbatical, so you haven't seen my face very much, but I've been very much involved with Devrina and my other PhD students working on all of their projects. So I'm going to start with kind of the formal introduction of Devrina and then say a couple comments about my reflections of working with her. So by way of background, before Devrina joined us here at UC Davis, she received her Bachelor of Medicine in 2013. She received her medical doctorate in 2014 and a Master of Nutrition in 2019, all from Universitas Indonesia. And prior to joining UC Davis, she also served as a researcher at the Human Nutrition Research Center at the Indonesian Medical Education and Research Institute, and as faculty of medicine at Universitas Indonesia. She began her PhD in 2022, and that was when I first met her in person. But actually, I was introduced to Devrina by way of Beth Prado from at least a year or 2 years before that, because Beth had raved about you, and she was so excited about the possibility of you starting here at UC Davis. And she had told me when you first applied that she was excited for you to come here. And when you first deferred by a year, that she was very disappointed. But she said, I have hope she is going to come here next year. And Devrina did. She came and she first started working with Beth as Beth's second PhD student, right? Or no, third. Yeah, Catherine was second, and then you were third. I've had the pleasure of working with her indirectly since then. And then after Beth passed away, Devrina joined my lab group full time. And I have to say a few words about what it's been like to work with her. She has, as those of you who know her, she has incredible enthusiasm and excitement for nutrition and public health. She is incredibly creative. I'm always learning about all these other projects that she's doing. She's developing apps. She's running, she's coordinating a community program. She is speaking at the some UN summit in New York City. I mean, she is incredible. And the other thing is I have such a hard time keeping up with even her dissertation work. She sends me drafts and I'm like, wait, I just sent you comments on this 2 days ago. And they're back on my desk. So I don't know if I should say thank you for that or
yeah, that's my mistake.
And then I hear about these other papers that she's doing at the same time. So this has been a real pleasure to be able to work with you these past few years. And I'm really happy to see you sharing this presentation with us today. I'm also very happy that you're going to be staying within the UC system for your postdoc. She will be transitioning to a postdoctoral researcher position at the Nutrition Policy Institute after this. And so we are really happy to see that you're going to be working not too far down the road and continuing to work on child nutrition going forward. So with that, I'll turn it over to you to do your seminar.
Yeah, thank you. Dr. Christine, that's very, very kind words. Thank you everyone who's joining in person and also on Zoom. I really appreciate your time to coming. So I'm so excited to present my dissertation finding on linking timing and context across sensitive windows of early life nutrition and neurodevelopment. So I've been always fascinated by how the brain works. Brain is really interesting. It is highly adaptive to pathological and physiological alteration in our body, thanks to its plasticity. Brain is also sensitive and demanding. It accounts only for 2.5% of our body mass, but consumes 20 to 25% glucose and oxygen. And this sensitivity and adaptability especially increased during this window of opportunity of brain development. From pregnancy to the first 2 years of life, our brain experiences a variety of processes, including neurogenesis, the creation of the synapses, the pruning of synapses, and myelination. And this really motivates my research vision towards preventing missed opportunity in early life. Nutrition is one of the most important factors that influence brain development. So I started my curiosity journey by doing a systematic review in 2019, where I investigated the effect of probiotics intervention on cognitive function among children and adolescents. And what I found really interesting is that probiotics only showing effects on autism-related outcomes. In 2022, I did a follow-up study of randomized controlled trials comparing different strains of probiotics, also showing similar findings where different strains of probiotics affecting different domains of development. So this really is the motivation behind my dissertation work, is to investigate what is this domain-specific matter. In fact, domain-specific effects of early life nutrition is not new. There's compelling evidence, especially from animal studies, that showing specific nutrients support specific functions during rapid growth or in certain brain areas. So I'll take an example of maybe one of the most investigated nutrition and cognition relationship, which is iron and recognition memory. So there is an increase of iron uptake and utilization at the same time, where also there's a rapid growth of hippocampus development. And hippocampus is responsible for recognition memory. So there are studies in humans showing this domain-specific effects between iron and recognition memory. It turns out that iron is utilized during this period for metabolism, including mitochondrial function. So there are complete evidence that domain-specific effects of early life nutrition exist. Despite that evidence, we still have challenges in evaluating these domain-specific effects of nutrition. In 2019, Dr. Beth published a large meta-analysis that showing the effect size of nutritional supplementation on cognition, language, and motor development were small. What I found most interesting in this meta-analysis is that despite the fact that we know that certain type of nutrient factors affecting certain type of developmental domains, most studies use global developmental tests, which may overlook the domain-specific effects of nutrition. On top of that, because they use global developmental tests, so then most tests have not been, they're not been originally developed in that countries and also not being validated in the countries of where the study is implemented. So this really brought to the key questions of my whole dissertation, which is the lack of measured effect of nutrition on cognition, is that due to a true lack of effect? Or is it because our inability to measure an effect? So in this dissertation, I propose that there is interaction or link that we need to consider between type, timing, and context to evaluate domain-specific effects of nutrition on cognitive development. So we start with the type of certain type of nutrition exposures and certain type of developmental outcomes, but we also need to incorporate the importance of timing. Not only about timing of nutrition exposures, but also timing of developmental outcome measurement. We want to measure these developmental outcomes where certain domains are still actively developing, but not mature enough, not too mature, so then group differences become undetectable. We also want to incorporate context, and context goes beyond whether a task has been validated or not into local context, but also different processing strategies that could occur in different contexts. So I'll take an example in a study by DeBolt in 2024, comparing children living in Malawi and the US. They used attention task, and they found that children in the US have a shifter movement of the eye related to attention, but it made them more inaccurate. On the other hand, children in Malawi, they are slower in shifting their attention, but it made them more accurate. So different processing strategies that different children use in different contexts, really important to make us thinking about which directionality that we expect when we interpreting the results of early life nutrition on cognition. So I like to visualize this interaction between type, timing, and context. like building a house. So when we construct a house, we need the wood, we need the brick, we also need the paint. This reflects different domains within cognition, such as attention, could be memory, could be language. And throughout the process of building a house, we want to start to make the framing first. So we need the wood first. And as it is getting done, now we will start using the brick. So this really reflects that different domains of development could mature at different time points. So there is a sliding sensitive period across different domains within development. And where context is important is that at the end of this building a house process, we have this beautiful and safe place for everyone to live in. It could look like this. It could be also look like this. So these two houses look different, but at the end of this process, they serve the same function, which is serving a safe place for everyone to live in. Similarly, when we measure different contexts, different children could showing different behavior in terms of cognitive development, but using that behavior, they adapt to their context. So they thrive with that performance. So really is the idea of dissertation is to be more intentional when we measure the associations between nutrition and any other developmental outcomes. We want to ask when we measure the exposure, when the outcome measurement was conducted, and also asking several key questions about context. Is there any different processing strategies that different children use in different settings? So moving on from only focusing on certain type of nutrition and certain type of developmental outcomes. So with this in mind, I propose 3 sections for my dissertation. The first section will explore an objective measurement, hopefully objective measurement of cognitive development that is able to detect domain-specific effects, as opposed to using global developmental tests of basic skills of infant development and so on. So we explore the use of eye tracking assessment. Building on this eye tracking assessment section, we will now explore the importance of timing. So we use more general factor of nutrition, which is growth. So there's no intentionality in terms of type of nutrition exposure, but we measure these outcomes at multiple time points. So we'll see if the associations between nutrition factors and cognitive outcomes vary based on these time points. And at the life sections, we will now incorporate all these hypotheses. We want to be intentional in terms of the type of nutrition exposures. We want to be intentional in terms of the time where supposedly we see something on cognitive outcomes, and also incorporating the importance of context across the sessions. So I'll start with the first journey, which is exploring this eye tracking assessment to measure domain-specific effects on cognition in nutrition study. This is my daughter, Priya, she's here. So, eye tracking assessment is really interesting. So infants and young children, they might have limited expressive language and behavior that we can capture, but the way they look at something could tell something about their brain and also cognitive development. So what we do in this eye tracking assessment, we expose children with stimuli on screen. And by looking at the stimuli, it activates certain areas in the brain, and we will capture their eye movement due to this activation. These domains could be we could capture attention, we can capture memory, we can capture language, depending on the stimuli that we used on screen. So this really describes the flexibility that we have with eye tracking assessment to measure domain-specific effects. We did a scoping review of eye tracking nutrition studies, where we include any human observational studies or trials that conducted from pregnancy to children aged 5 years of age, and with outcomes of cognitive assessment using eye tracking methods. We included 1,100 studies in this, we screened 1,100 studies in the scoping review, and at the end of this process, we included 9 studies. So as the result, we found that out of 9 studies included, only 2 studies conducted in high-income countries. This tells us 2 things. First, it is visible across settings. Second, it is underutilized. So eye tracking assessment is underutilized for nutrition studies. Some included studies also made adaptations to local context. For example, they changed the faces into using local faces, which is great. But what I found really interesting is that there is also a considerable variability in reporting. So the proportion of adult children who were able to be assessed range very wide, between 40% to 87%. So this says something about visibility of proper training for local staff. Now, before going to the main result, I will show you. This is just a different setup that we can use for eye tracking assessment, depending on the space that we have. The children could sit across to the assessor. The child can also sit next to each other with the assessor. Now, the results. So, just to quickly orient you with this table, we only found eye tracking assessment is used to measure attention and memory domains across nutrition studies. And we also will highlight the significant results with blue for attention and green for memory. So what we found in our scoping review is that there is a specificity in terms of timing of outcome assessment when we are able to detect an effect. And this really builds to the next section, which is exploring this time specificity. And it doesn't only occur for attention, but also in memory. So you can see that some associations found earlier, this really highlights the importance of choosing the right timing to measure cognitive outcomes. So with that, I'd like to summarize the key findings for the first section is that eye tracking is a visible method. And so far, we found studies related to attention and memory in nutrition studies, but we want to also highlight the importance of feasibility of proper training for local staff to implement eye tracking assessment. Now, building on the time specificity idea, I'll take you to the next section. Here we are asking how do growth patterns as the general factors of nutrition exposure is associated with child attention and memory across time. So we want to be exploring this time specificity. Growth patterns is interesting because children can have accelerated growth. They can also have decelerated growth, which expose them into different metabolic programming and neuroinflammatory process, leading to different outcomes on attention and memory. And again, we assess attention and memory at multiple time points between 6 to 15 months old. In this study, we used an unsupervised learning of latent growth trajectory modeling, which I will also discuss later. So we used two cohort data from two randomized trials nested in randomized trials, one in Malawi from Mazira project, and one from the US in IMAN project. So within each project, we have multiple time points of growth measurement, weight for Malawi and United States, and length for Malawi. So we can compare the ponderal growth between Malawi and US using this growth trajectories method. Before moving on to the associations between growth trajectories and cognitive outcomes, I want to shortly talk about how do we identify these growth trajectories, which I think is very interesting. The idea of growth trajectories here is that we want to classify children into different groups based on their growth patterns. So if they share similar patterns, they will be classified into one group. So for example, we have my daughters, Dana, Freya, and child A, child B, and child C having this accelerated growth that looking like this green line. So they will categorize into that group. And then we also have child D, E, and F who have more flattened growth. So then they will categorize into this red line growth trajectory groups. So using these groups, we can use these groups to forecast health outcomes, including cognition. The idea is pretty simple to identify these growth trajectories, get the longitudinal data of weight and length measurement across time, and run the model, refine the model until we satisfy the model adequacy criteria. And at the end of the process, we have this growth trajectory stratification for each child. And we will see if there's any differences on cognitive outcomes based on this grouping. So I like to briefly show you what the results look like when we compare the trajectories. So what I found really interesting is actually not that their growth trajectories are different across contexts, but there is similarities across these two contexts. So within each cohort for weight trajectories, we found that children having similar starting point at birth, but then they diverge notably by 6 months. And from 6 months on, these were followed by mostly flat or negative trends through 12 months. So this really indicates the importance of early origins from prenatal to the first 6 months postpartum. And I like to also give you, so the dark gray, the gray shaded areas at the back, this is the WHO standard trajectories. As you can see, some children do follow these trajectories in Malawi and in the US. So it's interesting to see similarities of growth trajectories between these two cohorts. Now, going to the associations between growth trajectories and attention and memory. We used eye tracking assessment to measure attention and memory. For attention, we used infant orienting with attention task or IOA task. In this task, I'll show you the task, how the task look like. But basically, we want to measure how fast children move their eye gazes towards the stimuli. It's a daily object that we show, that we expose them on screen. The speed, we capture the speed, so how fast children looking at the stimuli. We also capture the accuracy. So before showing them the daily object, we provide a black dot that serves as a cue. So sometimes this black dot is on the same side of the stimuli, looking like this. This is the stimuli. And then also it could be on the opposite side of the stimuli, showing like this. So when it is located at the opposite side of a stimuli, it could serve like a distractor. So we're also capturing how accurate the children looking at this daily object, although they were distracted by this cue, which will be captured as task error or measuring this accuracy. And for the memory, this is my daughter too. So for memory, we use visual peer comparison task. We capture the recognition memory. So whether children is able to detect a new face as compared to familiar face. So first we expose children with this similar identical faces. We change one of the faces into a new one, and then we do side reverse. We want to measure that the goal, the more robust recognition memory, should be shown by looking longer at the novel face as compared to the familiar face, which we measure as novelty preference. We also have a processing-based indicator. So how do children learn? We capture how long children looking at the familiar face, which is captured as peak look duration. Lower peak look duration is assumed to be more efficient learning. And then also we're capturing shift rates. So shift rates is how much shifts that children do between this phase to the other phase. So higher shift rates also means higher efficiency in learning. We assumed that shift rates is higher when they have more efficient learning. So with this task, again, we want to test the time specificity of these associations. We found that the associations vary across time points. So for attention, we found association with attention at earlier ages between 6 to 9 months old. In Malawi, girls in the start lowest and end lowest length for each z-score and length trajectory groups, which is showing with the lightest pink, showing poor attention in certain condition within that attention task at early ages. So there's also specificity in terms of condition, which I will not be talking about it now, but happy to take any question on that. These associations, though, we don't find the significant associations at later time points between 12 to 15 months old. Instead, we found association with recognition memory at later ages. So in Malawi, boys who started with the lowest intercept at birth and with the highest weight, so they have this accelerated growth, showing poorer memory at later ages, but not at the earlier ages. So if we zoom out, we have 2 time points of outcome assessment, early between 6 to 9 months old, and then later between 12 to 15 months old. We found that significant associations, which marked with this blue boxes, found for attention at the earlier ages and memory at the later ages. So it's really interesting to see this time specificity. And on top of that, we also found context specificity. Recall that we have the US cohort. We did not forget the US cohort. We just didn't find any significant results, significant associations within the US cohort. So it's also interesting to see this context specificity on these associations. I want you to remember that we see recognition memory at 12 to 15 months old. We will use this idea when we move on to the next section, the last section, which is about iron status and recognition memory at later ages. But before that, I'd like to summarize the key findings. We found that although there are differences in growth trajectories between 2 cohorts, trajectories for weight mainly differ by intercept at 6 months, suggesting the importance of earlier origins. And there are variations of the associations based on time points, sexes, and contexts. Before moving on to the next section, I'd like to promote my fun project. We are writing a methods paper to model early life growth trajectories. The idea is to have a wider adoption of this growth trajectory modeling among nutrition researchers or any researchers that have any indicators. So it's not only growth and length, any indicators that assess at multiple time points with the same construct. We could apply this latent class trajectory modeling. So in this paper, we discussed about how to clean the longitudinal data, how to refine the model until we get the model adequacy criteria. And if anyone is interested, anyone has multiple time points of weight, length, measurement, feel free to reach out. I'm happy to connect and collaborate. All right, so going to the last section, which is now, we're going to be more intentional in terms of type, timing, and context. We investigated the associations between iron status and anemia with children learning and memory, including recognition memory. So with this hypothesis, supposedly, we have to see something between anemia and iron status as nutrition exposure, very specific, on recognition memory. Again, animal studies showing compelling evidence. And we also measure this recognition memory at the time points where we supposedly see some things based on the previous section. But what could be also interesting is that let's test this domain specificity. We also compare these associations with attention and social engagement. So if our hypothesis is correct about domain-specific associations, we shouldn't see any significant associations with attention and social engagement with iron status. Before going on the methods, I like to just share a quote from Dr. Betsy Laloff, who has a lot of studies of iron and cognition. In one of her commentary in 2001, she mentioned about recognition memory and reaction times. And we did evaluate recognition memory and reaction times with iron status here. So we'll see if this is helpful to investigate this iron status as an exposure. We use the same cohort data from Mazira project in Malawi. We use assessment of anemia and iron status at baseline, which is between 6 to 9 months old. And this anemia and iron status indicators, we have them as a continuous exposures of hemoglobin, level of plasma ferritin, plasma soluble transferrin receptor or ACFR, and also by the iron index. We also categorize children into anemia versus non-anemia, having iron deficiency versus without having iron deficiency, and having iron deficiency anemia versus without iron deficiency anemia. As a refresher, what do we expect in terms of the directionality of this iron biomarkers? Plasma ferritin reflects the iron stores in tissues. So in the iron deficiency condition, we expect the plasma ferritin to be lower. And then transferrin reflect the receptor in our blood. So in the iron deficiency condition, we expect the plasma STFR to be increased. And anemia, of course, we expect in anemia condition that the hemoglobin to be low. Body iron index is basically a measurement that a calculation that combines this plasma ferritin and plasma SDFR. And we also expect the body iron index to be low in iron deficiency condition. We measure the cognitive outcomes with attention and memory, but also we add a new domain within cognition, which is the visual social engagement. I think time points of 12 to 15 months old is interesting because at that time points, children have this vast language development. So it also influences the way they engage socially, including the way they're looking at the face. So we expect children who have more robust social engagement, considering this language development, to looking at the mouth area more than other areas in the face. So we segment this faces into mouth and eyes, and we capture this mouth percent dwell time, which is proportion looking at the mouth, and compare them to the eyes percent dwell time, which is just the proportion looking at the eyes. Again, we expect if children develop better or faster, they have higher mouth percent dwell time. Eye mouth index just comparing the eyes and mouth looking time, and we expect this eye mouth index and eyes percent dwell time to be low. For the analysis, we use mixed effects model because we have multiple trials of cognitive outcomes task. But I just wanted to highlight that we also did a variety of subdivision analysis, which we will not explain it during this presentation, but I'm happy to take any questions if anyone is interested to any of these comparisons. We also we tried a causal inference approach of inverse probability weighting, but we dropped this analysis because we did not achieve covariate imbalance. But we did not achieve covariate balance using this IPW. So going to the results. I know you're so excited to see the associations, but I want to highlight that the burden of iron deficiency. So we do in MyZebra project, we do have 2 time points of anemia and iron status measurement, which is baseline between 6 to 9 months old and end line between 12 to 15 months old. This is a Sankey plot that's showing how children move across this anemia and iron status category. So the left side is baseline category. So we have non-iron deficiency and non-anemia children, children with only iron deficiency, children with anemia but not iron deficiency, and also children with iron deficiency anemia. You can see that only small proportion of children don't have any iron deficiency anemia. But then when we compare to the end-line assessment, it's even smaller proportion who stays at that group. So in the previous study, we reported that 77% of children had ID, but with this longitudinal approach, overall children, 93.6% of children experience ID at least once between 6 to 9 months old and 12 to 15 months old. So we highlight that the burden might be underestimated when we use only cross-sectional analysis. Now, going to the associations, which is the most exciting part. So I'd like to orient you really quick about this figure. On the y-axis, we have the effect estimates per interquartile range increase, meaning that how much the effect on cognition we could see if one child moved from the percentile 25 to percentile 75 from this distribution. So also we have x-axis of different cognitive indicators of each domain. We did not include attention because we did not find any significant associations with attention outcomes. And you will see there are multiple colors in this figure reflecting different biomarkers of anemia and iron status. And we also already inversed the plasma SDFR to make sure that directionality is consistent, that higher reflect better anemia and iron status among the children. Also, we have a background of dark gray area of each outcomes, which reflect that for that outcome indicator, higher score is better, with the light gray area, meaning that for that outcome, lower score is better. So as expected, we see that there is a significant associations between iron biomarkers with recognition memory. Yay. So we see that there is a higher hemoglobin is associated with higher novelty preference, although these associations were small, but we did not find any significant associations for novelty preference for plasma TFR and body iron index. Instead, we see significant associations between a TFR and body iron index for this more processing-based indicators. For hemoglobin, which I didn't really expect to see associations, but we do see significant associations between hemoglobin with social engagement, and this is pretty consistent across indicators. So higher hemoglobin is associated with higher looking at the mouth area, which is great. And we also see that higher hemoglobin is associated with lower looking at eyes area and lower eye mouth index. But we did not find any significant associations when we used the categorical exposure. And you can see that there are just a few significant associations, but that is within the sensitivity analysis. And I want to be very careful with that because we have there's an imbalance between groups when we do the sensitivity analysis. To summarize this last section, hemoglobin at 6 to 9 months old was associated with social engagement 6 months later, and iron biomarkers is associated with later recognition memory. So our hypothesis is hopefully correct, that there's the importance of type, timing, and context. And to incorporate context interpretation, we've seen that effect sizes were small. We think that it could be related to the fact that we measure these associations in high burn settings. So with that, I'd like to go back to our key questions at the beginning, which is linking the type, timing, and context. Key question is how, when, and in what context do we measure lab nutrition effects on cognition? We propose that first, it has to be multi-domain evaluation with sensitive measures. It has to be multiple time points to detect group differences, or at least to be intentional when we choose the timing of outcome assessment, and also context considerations to be incorporated in the interpretation. With that, I'd like to thank Mazira and Ayman project teams, all the collaborators, all the researchers, the field team, and especially the mothers, children, families, the communities that inspire this work. And I also have just a quick 2 minutes sorry, but my PhD life. So this is dedicated for all the persons that's important to this dissertation, especially my dissertation committee. They teach me that scientists with integrity and rigor being a scientist with integrity and rigor is more important than being scientists with statistical significant results. And my dissertation committee for that, and I think what's interesting is that at the end of the PhD journey, what I'm proud the most is not the publication and the awards, but it's that I see science differently. Science becomes a wiser way for me to approach things in life, in research questions, in anything, and that science is a powerful tool to help people. So I thank my dissertation committee for that. Thank you for introducing me to the complexity and nuances. So I got this. This is directly cited from Stewart 2026 in an email. She sent me all this complexity. So thank you for that.
It's true.
Yes. Yeah. I think like 3 days to just like, and also my dissertation committee is really great because they have this magical power to transform these straightforward trajectories into this more refined modeling of trajectory. Beautiful. And then they also have this sketch almost be in my publication, but Christine said no. And then so I tried to use a designer interior software to make this figure, and I'm happy with that. And then at one point, Lisa told me that Dafrina is trying to develop this area of interest, a triangle in nose. Like, this is not triangle. I feel disrespected. But it motivates me. No, I'm just kidding, but it motivates me. I love Lisa. Then I use machine learning to using the Google Face Mesh Media Pipe to better have a more refined area of interest development. So I thank you for my dissertation committee's very transformative journey. So I like to thank Dr. Kristen Stewart as my major professor. You've been an amazing mentor, but I like to thank you the most for making me very comfortable to be a curious scientist. And also that so I promise not to cry. So that every research question is rooted from sincere intention to help people, and that scientific rigor and compassion could coexist at the same time. So that is from Dr. Kristen Stewart that I learned the most. And then Dr. Lisa, at the very beginning of dissertation committee meeting, he told me that do high risk, high reward. So I do the high risk, I do get the reward. Sometimes I don't get the reward. So, I thank Dr. Lisa for that, because she really makes me comfortable to being challenged, being asked and asking questions, and that every failure that I see, it's not a sign of failure, but it's just a sign that my mind is working better. So I like to thank Dr. Lisa for that. And last one, Dr. Jenny. Dr. Jenny is here, but she has a really high standard for data collection. We had a plan for one chapter, which is now abandoned chapter, rest in peace. But I learned a lot from her that she is very rigorous in terms of data collection. I learned that from her, and she's so positive, always excited for any research question that I propose. And Dr. Beth, if not because of her, I wouldn't be inspired to do a PhD. And also being here at UC Davis, her warmth and her passion leads me to this, to here. And also Dr. Ken Maleta, he's always excited to every research question that I propose, always supportive. So I'm hoping he's here, but I just want to acknowledge his support and always open to any research questions. That amazing collaborator. And last one, well, not last one, but I would like to thank some people that are responsible to expand my research areas into more advanced analytics and nutrition, Charles, and then Dr. Kevin G and Dr. Micah. So I took classes with them. And what I found really interesting with statistics is that I found statistics because of them. Statistics is not intimidating for me. And I feel like statistics is just another language that I try to slowly learn. So I like that shifting my mindset, and that's because of these people. And last but not least, also friends and families, Stewart Lab, Oaks Lab, Art and Silo Lab, and then this is not an exhaustive list. And my best friend in Brave Project Indonesia, where I come from, and then also my family and friends, my Indonesian friends, my family in Indonesia who is on Zoom. I saw my dad on Zoom, and then also Dana and Freya. You are the inspiration that. You have the inspiration for us doing this work for children and mothers and families. So thank you for your love and patience with this journey. So yeah, thank you everyone.
All right. Well, we have a few minutes for questions. I'd love to open it up. Thank you so much, Tigrina. This was a fantastic presentation.
Oh,
Questions?
thank you, Dr. Jenny. Yeah, thank you everyone for coming. I just want to acknowledge some collaborators here. Aaron, Vienna is here, and then I think Michaela is here, and I get conversation with Dr. Maureen Black in ASN. So thank you for coming too. And then Hannah, my next supervisor at NPI. Thank you for coming. And yeah, Aaron. Dr. Rebecca Schmidt, I also send invitation. Thank you so much. And yeah, everyone who's coming, thank you. Appreciate it. And all my family's also here.
You do have a question?
Very general question. I've heard about your research now a few times, especially in IGM Lab, and it's been fantastic to learn all about it. You are very ambitious and just a rock star. And so driven and inspiring to the rest of the students, especially here in IGM. But just broadly, where do you see, or how do you see yourself disseminating this research and inspiring others to continue to connect, like you say, this research with the compassion and its context in its entirety?
Wow, that's a big question. I like to think research, I don't know if this would answer, but I like to think research, they have two components. First is the findings itself, so scientific findings, having more utilization of eye tracking assessment, because indeed we see this is underutilized in nutrition studies, and just being able to detect domain specific effects. So I think the idea of this hypothesis is that this is also my fault. So when I did a follow-up studies, I wasn't being intentional about timing of exposure and outcomes. So at the end of the research, we don't want to see like associations that are not intentional, if that makes sense. So like, this is a random association that we found because we do multiple hypothesis testing. So that is something that I like to try to avoid with this intentionality. So I'm hoping to see more eye tracking assessment or domain specific ideas with this consideration, type training and context hopefully in every nutrition studies on, especially in early life cognitive development or any developmental domains. I also see also the use of longitudinal studies, which I'm also excited about. In any studies, I think patterns tell us something, and we cannot see patterns if we only rely on cross-sectional. So I think that will be really exciting. But also I see doing research is also, there's also soft skill developed. So I think what I want to, with this message and all this intellectual curiosity, what I like to share a message is about believing, so finding this curiosity within you, and through a lot of readings, a lot of discussions. And I think one thing that I like to appreciate from this journey is that the research, I was able to come up with the research questions, and then my dissertation committee helps me to refine it. So for example, the growth trajectories, I want to do growth trajectories. And then Christine said, oh, maybe you can compare across contexts. And then I proposed that I want to see this visual social engagement task development. And then Lisa gave me references about comparing mouth and eye. So, oh, it could be used for language development other than the autism-related outcomes that I'm interested in. So being able to also developing this more kind of like the way we approach science, also something that I like to hopefully disseminate during my future mentorship as well. So yeah. Thank you.
Thank you.
Yeah.
Incredible as always.
Yeah. Thank you. Appreciate it.
Well, if there's no questions, I think we can finish. No more questions. I think we can finish up. So thank you. Congratulations.